Hello. In this video, we're going to use transformations to graph y equals -1/2 bracket x minus 3 squared plus 8. Now, of course, this video is about doing a detailed graph, and for the most part, you wouldn't actually do this. If you wanted to do a detailed graph, you would use some sort of graphing software. What we're more interested in is sketching graphs to get an idea of what it looks like. But being able to do a detailed graph using transformations is really useful, especially as you head into some other concepts in later years. So the first thing, before we do this, let's just do a sketch so we have an idea of what this is going to look like. So to do a sketch, I'm just going to make a quick little XY grid here. And let's start by stating the critical information here. We know that this parabola opens down because A is negative. We know that there's a vertex at 3, 8. And again, we can read that directly from the equation because it's in vertex form. We know that it has a max because it opens down. The max occurs at 3, 8. We know that the axis of symmetry, which I often notate AOS, axis of symmetry is x equals 3. And again, we always want to write our axis of symmetry as an equation. And now that we've covered the main points about a vertex, let's just take a second and calculate the y-intercept. So we're going to find the y-intercept, so we'll set x to 0. Oh, pardon me, we're just going to get the eraser here. Grab the eraser. We're just going to set x here to 0, minus 3 squared plus 8. So I'm going to get my calculator out and plug that in my calculator in one step and get the value. And we get a value of 3.5. And now I have enough information to draw a quick sketch to get an idea of what this looks like. So remember, with the sketch, I don't need a scale. I'm just going to kind of put a point, 3, 8. Again, these are approximate. I know it opens down, so I'm going to kind of do this. And now that I know that this has a y-intercept greater than 0, so I'm going to make sure I cross here. That's kind of the useful point here, finding the y-intercept, because it tells me whether it crosses the y-axis above or below the x-axis. So we'll say 0, 3.5. And if I wanted to, if there was some reason, I could do a number of things. I could find the x-intercepts, I could calculate some points by substituting in. And in my sketch, sometimes it's nice to put in that axis of symmetry. So let's just find the x-intercepts here. So to find the x-intercepts, we'll set y to 0. So -1/2. 0, oh, pardon me, not 0. X minus 3 squared plus 8. So we get -8 is equal to -1/2 x minus 3 squared. We'll multiply both sides by -2 to clear that fraction. So we get 16 equal to x minus 3 squared. I'm going to take the square root of both sides. So the square root of 16. And remember, because I write the square root, I have to put plus minus. So therefore, the first x-intercept is going to be +4 plus 3. And the second x-intercept is going to be -4 plus 3. So again, plus root 16 is +4, minus root 16 is -4. So we get x-intercepts at 7 and -1, which I feel good about because if I come up here to my sketch, I see I have -1, 0, 7, 0. So again, this is good enough for the most part in terms of using this to analyze and help us work through situations. But let's graph this using transformations. So let's come over here. So the first thing I'm going to do is I'm going to state my transformations. There are three types of transformations we need to be aware of. We need to be aware of reflections, we need to be aware of stretches, and we need to be aware of shifts. Shifts sometimes called, shifts sometimes called translations. So I'm going to read this example. There we go, from left to right. The key thing with transformations is you always do your shifts last. So the negative a value means that the first transformation is I have a reflection across x. The 1/2 means I have a vertical stretch by 1/2. The -3 means we shift right by 3. And the +8 means I shift up 8. So I've read this from left to right, and I've stated each of the transformations. So the way this works when we graph using transformations is we have to start with a parent graph. And the parent graph in this case is a quadratic, y equals x squared. So I'm going to start by graphing y equals x squared. So you can actually just test some points to calculate this. So this is y equals x squared, right? 0 squared is 0, 1 squared is 1, 2 squared is 4, 3 squared is 9, -1 squared is 1, -2 squared is 4, -3 squared is 9. By applying each of these transformations, we're going to take this parent graph and we're going to end up with something that looks like our sketch. So what I typically like to do when I do this is I like to group the reflections and stretches, and I do those in one step. So I'm going to do these two in one step, and then I'm going to do these two in one step. And I'm going to have one intermediate graph. So I'm going to choose some points on the parent graph to apply the transformations to. I recommend using 0, 0, 1, 1, 2, 4, and 3, 9. You can find, you don't need to take the other branch because a quadratic is symmetrical, meaning you can use symmetry to calculate the corresponding point. Notice the distance from this point to the axis of symmetry is 1, the distance from here to here is 1. So the first step I'm going to apply is let's do this first step in pink. We're going to apply the reflection across the x, which means I'm going to take all the y values and multiply them by -1. And we're going to do a vertical stretch by 1/2. So we're going to take all the y values and we're going to multiply them by 1/2. Now, an important thing here to remember is that a stretch is never negative. The stretch factor is always positive. The negative implies a reflection. So 0, 0. So the x is going to stay the same, and 0 times -1/2, because that's essentially what I'm doing, because we're applying transformation 1 and 2, it's going to give me 0. 0, 1 times 1/2, -1/2 is -1/2. Oh, pardon me, that's not 0. So that's 1. So the x value doesn't change. 4 times -1/2 is -2. X doesn't change. 9 times -1/2 is -4.5. So what I can do now is I can plot this first step after the first two transformations are made. So 0, 0 stays 0, 0. 1, 1 becomes 1 -1/2. 2, 4 becomes 2 -2. And 3, 9 becomes 3 -4.5. So there's that branch there. And again, I don't need the left side, because if I know that's 1 over, 1 over, 2 to the center, 2 across, 3, 3. That symmetry is a really useful thing to take advantage of. It reduces the amount of work you have to do. So the pink is after we've applied the reflection and the stretch. So then what we're going to apply, and let's do our last step in, let's pick a new color. Let's do our last step, I don't know, in aqua, sure, why not? Okay, so this is, now we're going to apply step 3 and 4. 3, 4. So I'm going to take, to shift right by 3, I'm going to take all the x values and I'm going to add 3 to them. To shift up by 8, I'm going to take all the y values and I'm going to add 8 to them. So 0, 0 moves to 3, 8. 1, negative a half, so if I add 3 to 1, it's going to be 2. Add 8 to negative a half is going to be 7.5. 2 plus 3, oh, I'm sorry, I did my math wrong there. Pardon me. 1 plus 3 is going to give me 4. There we go. 2 plus 3 is going to give me 5. Negative 2 plus 8 is going to give me 6. Then we have 3. 3 plus 3 is going to give me 6. And now negative 4.5 plus 8 is going to give me, let's see, it's going to give me positive 3.5. So positive 3.5. So now that I have these points, I'm going to plot them. So we're going to come 3, 8, which is right here. We're going to come and we're going to do 4, 7.5, which takes me to right there. We're going to do 5, 6, which takes me to right here. We're going to do 6 across, 1, 2, 3.5. And now I'm going to dot in the axis of symmetry. And I'm going to kind of give the pairing points over 2, over 2, over 3, over 3. Notice my y-intercept matches. Now you'll notice, based on the points that I've transformed, I can't kind of extend this all the way. So this is a step where I either am going to add a couple more points and transform them, or I might find the x-intercepts, or test a couple values simply by substituting x in. But we've already found the x-intercepts right here. And we know the x-intercepts occur at 7 and negative 1. And now I'm going to continue down. Now watch here, the temptation now is to kind of, students sometimes shoot this out kind of in this direction here. I might want to figure out what this function is. I might test a point. So let's test x equals negative 2. So we're going to say y equals negative 1/2 negative 2 minus 3 squared plus 8. And I think it's a really good technique to be able to plug this in your calculator in one step. So let's do that. And when I plug this in my calculator, I get negative 4.5. So that's going to be about here. And then I'm going to kind of continue down like that. Okay. So again, once you've done these steps, you can always test some values. And that's how we graph using transformations. It is a bit of a longer process. As you get better at it, in fact, you don't write anything. You can just kind of put your pencil at that point on the parent graph and walk through it. And like I said, sketches are actually far more useful in the grand scheme of things. But this idea of taking a relationship and identifying the transformations from it and then seeing how to transform each point is a very useful technique and will come up again and again in many future math courses. I hope this helped.